All right, this is the review of the quiz that we just took over 17, 18, 19, 20, 21. Here's what the point values are. So this one's worth 5, and 17 is worth 5, 18 is worth 5, and each of these are out of a total of 4. So if you kind of look at those as you're working, that's going to help you out. Let's look at special right triangles. First one, we need to know NR is 13. Okay, so NR is 13. That means that this is the hypotenuse, and this is the short leg, and this is the long leg. And if you remember, the short leg, so 2 times short equals the hypotenuse, okay? And then root 3 times short equals this one. Well, that means that if this is 13, then this is 13 over 2, okay? So put the answers in red. This side is 6.5, and that makes this 6.5 square root 3. Okay, so those are my two answers. Over here on this one's a little bit tricky. Okay, so 2 times the short leg, so 2x, because this is the short, because over here is 30. 2x is going to equal y, and also x square root 3 is going to give me my long leg, which in this case is 12. Well, when I solve this equation, I know that x is going to be 12 over root 3, or if I simplify that, reduce radical form, okay, that's going to be 12 root 3 over 3 is 4 square root 3. So it's either this or this. Then all we need to do is multiply, because 2 times x equals y. So 2 times 12 over square root 3 is 24 over root 3, because it's really like 2 over 1, so it's multiplying fractions. Or you could do the same thing, 24 over root 3 times square root 3 over square root 3 is going to give us 24 root 3 over 3, which is 8 square root 3. And if we had multiplied this by 2, we would have gotten 8 root 3. Okay, so that's a little bit of work there, but I think these two options up here are going to be your best ones. Down this way, 45, 45, 90, so that we know that the two legs are the same. So this is also x, and x root 2 is equal to the hypotenuse. So if this is what's multiplied times root 2, then x has got to be equal to 9 in that case. Okay? Moving down to polygon angles. When we're looking at polygon angles, we've got to know what shape we're dealing with here. And if we're dealing with a shape that's got 1, 2, 3, 4, 5, 6 sides, my total number of degrees is going to be 6 minus 2 times 180. So my total is going to be 720. So I've got 120 plus 90. So I use this one, plus 110, plus 130, plus 160, plus x equals 720. Okay, and from there you can fill in those steps. We'll solve the algebra equation and find x, and that's going to be our angle here. Okay, try that one. Here we have a similar situation. I'm going to count my number of sides. And in this case, I'm going to have 5 sides. So 5 minus 2 times 180 is going to be 3 times 180 is 540 degrees. Well, it's 540 total. Well, what are the angles? Well, if I look at the angles are going to be 5x plus 2 plus 3x plus 5 plus 8x plus 8 plus 4x plus 15 plus 5x plus 10. Did I get them all? 1, 2, 3, 4, 5. Yep. And so that's equal to 540. So we'll combine our like terms and solve for that x. And they asked us for the value of the variables, so that's going to be sufficient. Down here in these two, we're dealing with interior angles in one of them, but exterior angles in the other. So exterior angles always equal 360. So in this case, I've got 1, 2, 3, 4, 5, but they all add up to 180. Sorry, 360. Y plus 40 plus 65 plus 60 plus 70 equal 360. I think most of the battle is knowing what to set it equal to, but when you're dealing with exterior angles, you obviously have 360 always. And then if you have some other number, like up in these two problems up here, it's going to come from the number of sides. So determine your number of sides if you're dealing with interior angles, and exterior is always 360. Same thing here. So here, a little bit trickier, right? First of all, let's notice this triangle here is it's an isosceles, so this is actually going to be x here also. Why does that help us? Well, if we can find one of them, we know the other one, and then these are a linear pair. This one takes a little bit of reasoning. This line here is 180 degrees. So if this is 145, then that means this one's got to be 35 degrees, right? Well, the total of these three is 180. So x plus 35 is 180. Okay, so 2x equals 145. Follow that down to find x. And then we know that x plus y, those are also on a line, so x plus y equals 180. So when you get that answer from up here, you're going to plug it in here to solve that one. Okay, so take a look at that problem. Let's talk about parallelograms for a minute. We obviously know that opposite sides are equal, opposite angles are equal. We know that consecutive angles are going to add up to 180. We know that there's going to be a lot of stuff going on with the sides and the angles, but we've got to determine what we've got. Well, this is a diagonal, so the diagonals are bisected. So that means that x plus 40 equals 2x plus 18, because diagonals bisect. So use that information to help you solve that one. Here, same way. We got to know opposite sides are equal. So we're going to solve two equations. Number one, 12 equals y plus 3. Also, 2x plus 9 equals 6x minus 7. Okay, so those are the two equations we're going to solve. Opposite sides are congruent like this. Okay. Down here, is it a parallelogram? Well, a lot of different things go into it, but first of all, opposite sides are congruent, so we can mark it kind of this way. Boom, 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 boom. Well, that also means that this is true. So these are parallel because they're evenly spaced. Well, then you've got MZP, 88, 88, 92, 92. Opposite sides congruent. You got parallel sides. Okay, there's a lot of reasons, but the bottom line is yes, and you've got several reasons why that is actually true. Let's go through 19. Same thing here, special parallelograms. Okay, so this is a special parallelogram. So 2x plus 4y equals 4x minus y. Well, I gave you credit actually if you set this up. But really in the future what I'm going to want is something that looks like this. If I subtract to get everything together, should be something that looks like this. 2x equals 5y. So if I'm finding the value of the variables, really I'd have to do something like this. X equals 5 over 2y. So that would be my x. Well, then if 2x equals 5y, then I divide by 5. X, so 2 over 5x equals y. Okay, so it's actually an answer that has two variables in it, but that is what x equals. It equals 2.5y, or 5 over 2y. Y equals 2/5 x. something that tripped up a lot of people on this one. This is a rectangle, okay? So angles have to be 90. So if I ask for ACD, okay, it's part of this 90 degree. Well, remember, this is also a parallelogram, right? Opposite sides are congruent. So these angles are alternate interior. So this is actually 32 degrees here. AC, sorry, that was ADC, so sorry. ADC, this should be 90. ACD should be 32 because those are alternate interior. AOB, well, how do we figure this out? Well, remember, we're dealing with a triangle here that has sides that look like this. Because rectangles, it's a parallelogram, so they bisect each other, but they're also congruent. So this is 32. Well, that's 32. Then this angle here, I've got this triangle. It's got two angles that are 32. 180 minus 32 minus 32. So 180 minus 64 is 116. Okay? So AOB, 116. Because that triangle there has that special setup of being isosceles. Trapezoids. Got to know the properties. These are trapezoids, so these are parallel, which means these two are supplementary. So 64 plus 4 times 3y plus 2 equals 180. That's an equation you can solve. This one, it's the average. So 21 plus 35 over 2 equals x. This one here, you have the answer. But 22 plus the bottom over 2 equals 15. So I multiply both sides by 2. 22 plus x equals 30. That's an equation. Measure of angle D. Remember, same one we used here in A. These angles that are parts of the two bases. So you can't use, A and P here, but you can use T and P or R and A. Same thing here. B and A are supplementary. C and D are supplementary. Well, this is an isosceles trapezoid here. So this is 115. So 115 plus the measure of angle B, measure of angle A equals 180. Okay? Do a little subtraction there, you get 65. Kites. Quadrilaterals. Total 360 degrees. That is 4 minus 2 times 180. And so you know that these two in a kite are the same. Well, if you want to label them x, you got 130 plus 60 plus 2x equals 360. Okay? So we got 360 minus 60 would be 300. 300 minus 130 would be, you can solve that equation. Same thing here. Just like these two were congruent, these two are congruent. So this is 113. Enter the 360 fact. Well, 113 plus 113 plus 44 plus the measure of angle F equals 360. That's a subtraction problem. All right, guys, thanks for watching. I think by and large, we just made some small mistakes on this one, but study this video, study the strategies that we use, not necessarily the specific problems, but the strategies, and you'll be all right on that next one. Keep up the good work. We'll see you next time.